Welcome, and thanks for joining us here on Code It Live, which is a channel we use for a lot of different things. But today it's a special one. It's a user group meeting, and I'm just glad to be here. I'm your host, Sam Basu. With me, I have my very good friend here, Matt. How are you?
I'm good, Sam. I'm happy to be here. Always like speaking to this group.
Yeah. No, we always love having you here, and I'm actually super glad that it's you this month because, like, we meet. If you're just joining us new, this is not like a everyday coding stream. This is once a month. Our user group gets together and we talk about things that we are passionate about. We bring on amazing speakers like Matt, and we all try to share and learn a little bit more. So this is the February meetup of what used to be called the Columbus App Dev User Group, and there's been a small change, and Matt is going to laugh at me for eternity. So let me let me share my screen, and perhaps Matt will give out a little bit of our age in doing so, but it's fine. It's history that we're living through, right? All right, so that is my screen that you're looking at. Okay, so one more time, welcome, folks. Welcome, and this is what you are in for. It's a user group meeting, but we are going to take this opportunity to kind of step back a little bit with history, because we are a little bit old. We have kind of done this. I remember, Matt, like 2008, 2007 is when I was kind of getting into the developer community, trying to go out and learn at user groups, and anywhere I would go or anywhere they would have me speak. So I think it was 2009, and Windows Phone was the rage at that time. It was all like mobile, and I had like a Palm Trio. I had other Windows mobile devices, but this was new. It was a brand new OS, which had great user experience. And Matt was one of the early adopters. So was I, and Doug Mayer, who runs this group with me for years. So we are in our like 13th or 14th year now, actually, in this user group. So we started out as CowPug, which is a funny acronym. It was Central Ohio Windows Phone User Group, because I used to live in Columbus, as does Matt and Doug. So we were, up and around Columbus, and we, had fun for like 2 to 3 years. Maybe even a little bit more. And then we kind of evolved into a little bit more generic. This was the time when Microsoft had launched Universal Windows Platform. So we're talking about the same apps running on phones and tablets and Xbox and HoloLens. It was a good time. And, we dug into Windows Dev for some time. But then we realized, hey, things are getting a little bit more, cross-platform friendly. It's not just Windows, it's Mac, and iOS and Android have always been there. There's AR, VR, there is, voice, and then so many other avenues where people are building apps. So we kind of adjusted ourselves to call it the App Dev User Group, which is pretty generic. And then the global pandemic hit, and we have been hopefully we are coming out of this mode, but a lot of things are remote, and our user group has been virtual. Nothing really has changed. We just miss out on having pizza and hanging out with friends, but we don't have to fight traffic. You can do this from the comfort of your home. So we are kind of embracing this, and we are going all digital. And the thing that we have kind of really benefited from is because we meet online, we can get speakers from all around the world, and that's wonderful. So we are, renaming ourselves a little bit to Global App Dev User Group. We have a brand new shiny logo with all of my design skills, which are next to zero. But we have updated all of our, internet presence. So website, Meetup, Twitter handle, everything is updated, and we'll keep meeting right here, third Mondays each month on Twitch. And if you are just joining us, we do have a Meetup group where you can sign up to say, hey, I'm going to show up, and then if you want to kind of be a little bit more informal off air, then we do also have like a 10-15 minute Teams call after the main talk. So we just kind of hang out and it's kind of our chit chat way of grabbing pizza with friends, which we can't do. So Matt, I'm actually glad that you are here because you have been with us on this journey from the very get-go. What are your thoughts?
I'm fairly certain that I've given a talk, at least one talk, at every version of this user group.
Yes,
but I'm also greatly amused that you changed the name, and when you change the name, you still get your first speaker from Columbus. So
yes,
you got to branch out a little bit more.
I know we will, but I mean, we have to, pay homage to our history, right? And
Of
you
course.
are one of the original speakers, so we are delighted to have you around, for years and years. And I don't know if Doug is around. I see our some of the folks are showing up in our chat room, our friends, which I'll highlight your stuff in just a minute. CGT Yoder, hey, good to see you. The logo looks great, Conrad. Thank you. But we will keep finding speakers from all around the world and just invite them over to come and share their knowledge. So that's how we're going to roll from this point forward. We still have the same sponsors. We get supported by Microsoft and Progress Software, and we do partner up with Visual Studio Live, which is a series of conferences that happen. We get a big discount if you're ever going to one of those. So we always like to highlighting a couple of things that are coming up regionally and also maybe globally now. But again, we'll kind of keep our sister group in mind. This is the Columbus.NET user group, and looks like they meet the fourth Thursdays, and some months it happens to be the same week. And they're meeting this Thursday, and the speaker is not somebody I've ever heard of. So that's fun. Matt, you're being busy.
I'm busy this week. Yeah, I'm still working on some of my slides for Thursday, if I'm being honest with you, but
Nice.
that's okay.
Nice. So that's the Columbus.NET user group. And there are more user groups around Ohio and everywhere, JavaScript or, Salesforce, whatever floats your boat. Go learn with your fellow, developers. So a couple of conferences that are coming up. CodeStuck is one of my, beloved conferences to go to, coming up in Knoxville, Tennessee, in early April. This is in person. Then we have Star Trek coming up, and again, Matt is involved with Star Trek. So, Matt, do you want to maybe spend a minute talking about this? This is May 6th, right?
Well, first I have to correct you. I'm not involved with Star Trek. I just love the conference very dearly.
Oh, I see. Okay. Yes, as
it's
do
my
I.
home. I go every year I can. I think I've only missed 2 or 3 years over the
me
years,
too.
but it's a wonderful conference.
Yeah, and it's a movie and a conference all together. So I think this time it's Doctor Strange, right? Yeah.
Multiverse of Madness.
There you go. So, combining the best of Marvel Cinematic Universe, sometimes other ones as well, with a full day conference. And you get to watch a movie and eat popcorn at the end of the day. What's not to like? So that's coming up early May in Columbus, Ohio. Again, this is our, partner, Visual Studio Live, and they do conferences all throughout the country. They were supposed to have one in Vegas in March, but that's something they're canceling because COVID rates are going down. But again, it depends on how comfortable people feel. But this one is on. This is Austin, Texas, coming up in mid-June. So again, if you have a little bit of budget from your company, come and hang out, with fellow geeks. So with that, I am delighted to present Matt Eland. I've known Matt for years and years. Amazing human being, and just an all-out, teacher and learner, lifelong learner. So you have been tinkering with data science, and I'm a little scared.
You should be if you know what I get up to with software engineering.
All right, so that's it, folks. I'm going to stop here and let's move some windows around. And Matt, I'm going to bring up your desktop if you are ready.
Okay, that sounds good. I do hear my dog upstairs barking. I'm hoping that he's going to die down a little bit in a second here, but my wife's out this evening. So if it gets too bad, I might need to pause, but we should take it by ear.
Yeah, floor is yours.
All right. Thanks again, Sam. So I am Matt Eland. I'm an instructor at Tech Elevator, where we teach software engineering. I'll talk more about them in a second. But before I started teaching new developers, I worked in the software as a service industry, particularly with Microsoft products, JavaScript, C#, .NET. I love it. It was a lot of fun. But it turned out that I liked developing humans even more than I liked developing software. And so that's where my heart has gone. And I've invested the last 2 years now just as an instructor over in Tech Elevator. If you're not familiar with us, we're primarily in the northeastern United States, but we have a virtual presence throughout the United States as well. We have an intensive 14-week program in either Java or C# where we make full stack developers. And we also are launching a part-time program as well if you can't go that full speed ahead. But our instructors are all like me. They all have extensive experience with the things that they teach, and they all love mentoring and helping others learn. But this talk's not about that. This talk is about what I'm doing when I'm not doing that. So for fun in the evenings, I have been delving into data science for the last, I don't know, half year or so or more. I run a YouTube channel out there called Matt on Data Science. You can go to mattondatascience.com to redirect you to that. It'll take you to YouTube. And my goal is to help people understand machine learning, get started with the basics, particularly on the Microsoft stack around Azure and things like that, ML.NET as well. But actually, as of last week, I have just started my own master's program through Franklin University, where I'm pursuing a Master's of Science in Data Analytics, machine learning, and things like that. So I have a lot of experience learning the basics of data science and machine learning is really what I will say. So I am not an authority on data science or machine learning, but I'm one of the better people that you might meet about learning the basics of these things and getting started. And that's what our talk today is about. It's about how would you go about learning the stuff, what's out there for you to explore, and what's the best way for you. I'm assuming here that most of you watching this are developers or people interested in development to dabble into data science. So I'll be very happy if you come out of this with a deeper understanding of what data science is, a deeper understanding of what machine learning can do, maybe some of the risks involved with it as well. I want you to understand who does data science and what kind of skills they might need. And then we'll look at some routes to get into data science, maybe without even leaving your dev job if you're currently a software developer. So I want to just give you a basic survey of data science. This is not going to be a code talk. This is going to be just a conceptual talk. We're giving you a broad exposure to the concepts out there. One note before we get any deeper, I have a lot of things that I'm covering, and I'm going to have URLs on the screen, but in the upper right corner of every screen, there's going to be this URL to matteland.dev/tryds. DS here is data science. And if you go to that URL, you're going to find resources for everything that I'm talking about, as well as some more things. So articles and videos, links to more helpful content, courses, anything that I think would be helpful for you. I'm also on Twitter at IntegerMan. So if you'd like to find nerdy things that I tweet about, go ahead and follow me there. You can also connect with me on LinkedIn, but please personalize the message so I know the context of it. But with that, let's get a little bit deeper into data science and what we can do with it.
Well, what did the squirrels ever do to you, Matt?
They amused me greatly. Actually, asked me about that in our hangout time afterwards. I have some interesting stories about machine learning and squirrels. But yeah. Yes.
No, and before you start, like this is the thing about you that just amazes me. Like you are just such a learner. Like you are, a veteran in our software industry. You've been doing this for 20 years now, but you are still, getting a master's degree, always learning. So please teach us.
Yeah, I am firmly under the assumption that even if I devote 100% of my time to learning software engineering and all the ins and outs of it, there's so much more new things coming out every day that I'm never going to be able to be an expert in everything. But that's okay, because we have lots of people out there. But data science is awesome. Data science is one of those things that we've been hearing a lot more about over the last decade and change. And one of the reasons for that is the increasing prevalence of data in software development. So nowadays, more and more organizations are on cloud computing. They're taking advantage of cloud storage. So using a data center like AWS or Azure or Google Cloud or IBM or whatever it might be to store your data. We have an emergence of Internet of Things devices, IoT, where we have more and more sensor data coming all the time. We have a vast amount of users using things all over the place. Our internet connections are getting better gradually over time. And as a result, we have more data that's coming in. And we can't possibly work with it normally. We need to have some new technologies to help us sift through the data and help us point us in the right direction, find insights and things like that. That's what data science is all about. It's about finding insights from the data that we work with. The tools and languages and technologies around data science have been getting better over the years, particularly in the core languages, which we'll talk about in a bit. But there's also been a leadership change as well, where organizations are really embracing this idea that data is valuable. Data is one of the most valuable commodities that any organization has. And what you do with your data can differentiate you from your competition or help you survive in a very competitive market. So this is why we're seeing data science being talked about more and more. But in reality, it's been around for probably about as long as I've been in computing, just under different labels, under statistics and things like that. Let's talk about some terms related to data science. So you've probably heard the terms artificial intelligence, machine learning, and deep learning. These are interrelated terms, where artificial intelligence contains machine learning and machine learning contains deep learning, almost like a nested doll kind of an approach. Now, artificial intelligence is the development of computer algorithms to emulate human or animal decision-making processes. That animal aspect of it sounds kind of weird, but we have things like ant algorithms and flocking that we've been using to simulate things actually for quite a long time. Artificial intelligence is really just trying to make a machine intelligent. Things that are artificial intelligence that are not part of machine learning are going to be things like game AI. We have behavior trees. We have a lot of game logic. We have rules-based systems such as decision trees and some expert systems, things like that. And then we have chatbots. Things that are giving you an intelligent customer support experience or search experience on a website. Those are technically artificial intelligence, but they're not directly machine learning, though they may take advantage of some machine learning resources. Now, machine learning is a subset of artificial intelligence. And inside of machine learning, we're basically applying statistical and mathematical techniques to extract insights and make predictions from a set of data that we either have studied before or just analyzing raw data and finding trends in that. An aspect of machine learning is depicted right here. This is a neural net. A neural network is supposed to emulate the structure of brain cells. So you have a neuron, and it's connected to other neurons with dendrites. And so you have these kind of biological connections between these different nodes. And if you chain these things together, they can kind of come up with a sort of a calculation. So you get all of these neurons together in a neural network, and you basically feed it in a set of inputs, and it spits out a set of outputs. It's almost like a really fancy calculator that emulates a biological process. Sounds kind of weird to describe it that way, but it's a way for a computer to play with different importances of the connections and the configurations of the connections and try to optimize it with mathematics to learn a set of inputs that should lead to a specific set of outputs. So that's all a neural network is. It's a connection of these little simple connections. Deep learning is an application of neural networks. So if you imagine a simple neural network like the one we have up here, deep learning is more and more complex neural networks. So we have additional layers of these networks, additional complexity in our networks. And these are just neural networks of a sufficient complexity and scale that they can start to do more advanced things. For example, if I showed a deep learning algorithm a picture of a squirrel or something like that, if it was trained to recognize squirrels, it might use its various layers to say, oh, I see the color brown in here. Oh, I see the poofy bits of the tail here. And it's starting to learn to extract features. So you see deep learning applied for image recognition, speech recognition, and a lot of really more complex things around machine learning. It takes longer to train. It takes longer to understand how this thing even works. But it allows you to do more and more powerful things like speech recognition, image recognition. So these are the three basic domains of machine learning and data science. But as you're starting out, you're going to be focused on three specific techniques inside of machine learning. So there's a lot of things that we can do with machine learning, and we're going to talk about a lot of them in a bit. But the three core ones that I want you to focus on if you are considering getting into data science are going to be classification, regression, and clustering. These are the three basic or core types of machine learning that I would really strongly nudge you towards. We'll talk about each one of these in a little bit more depth here. So
real quick, Matt, before you're moving forward, chat room, you're here, and Matt is, even though he says he's not the expert, you can see the amount of time he spends. So please fire away questions, anything you might want to ask.
Mm-hmm. Happy to help. And if you think of something later on, you can always tweet at me at IntegerMan, or you can email me at matt@mattondatascience.com. I'll have my email at the end of this as well. Regression is a way of predicting a specific numerical value given a set of historical data. So let's say that I'm going to open up Matt's used spaceship emporium, right? And I have a bunch of historical data about how spaceships are sold. Spaceships that have gone a certain number of miles sell for this amount of money. Spaceships that were built in this year are of this color. They typically sell for this amount of money. And I might have a whole bunch of information about historical sales records for my spaceships, because I'm not going to be boring and go with cars here. It's a fun meetup, not a car dealership. But you'd have a bunch of historical data around these things that you might have sold before. And these are all features. And you'll also have a label. That's something that you're trying to predict in the future. In our case, we might want to predict the price that we might want to sell our spaceships for. So with machine learning, you could do supervised learning and do regression. And it's basically saying, hey, I'm going to memorize all these past sales, all the features of these spaceships that you sold, and the price that you sold them for. And the reason why this is valuable is now that we have our trained machine learning model, we can take information about a new spaceship that's coming onto Matt's used spaceship lot, and we can plug in the information about that, such as the year, the miles, the number of accidents it's had, whatever it might be. And our regression model can predict a price for that. Even though it's never seen that particular configuration before, it's learned the relative importance of other features such that it can predict a numerical value. So regression is all about taking a look at a set of features and predicting a single numerical label or that value. So getting a little bit less ridiculous, but still a little ridiculous, I have built a regression model in the past to predict the number of minutes I would need to spend scraping off my car in the morning. I'm a notorious night owl, and so I trained this by collecting weather data via APIs, recording that in the database, and also I would manually enter in the amount of time I spent scraping off my car in the morning. And over time, that algorithm learned, given the overnight weather predictions, the time that I should be waking myself up in the morning so that I would have enough time to scrape off my windshield and get to work. Because heaven forbid that I wake up 15 minutes early if I don't need to. And that actually worked pretty well for my car in that spot. That's a fairly ridiculous use of regression. A more realistic use might be predicting stock prices or temperatures or something like that, something numerical. Now, if regression is predicting a numerical value, classification is predicting a categorical value. So we're not predicting a number, but a category that something is going to belong to. Last fall, around Halloween, my wife and I got into what we will call an interesting discussion as to whether or not Die Hard was a Christmas movie. And I decided that I was going to build a classification algorithm, and I was going to train it on a bunch of movies, whether or not those movies were Christmas movies. I wasn't going to include Die Hard in it, but I was going to train it on all these movies. And it was going to learn basically what categorizes a movie as a Christmas movie or not a Christmas movie. And after it had trained that model, I was going to feed it the information about Die Hard, and it would spit back whether it predicted it was a Christmas movie or not a Christmas movie. So that's an example of a classification algorithm. A more serious example might be predicting whether or not a mole is cancerous or whether or not we should approve a loan. But we're moving something into a category, or one of several categories. Now, this is an example of a binary classification problem. So it's either a Christmas movie or it's not a Christmas movie. You also have examples of what we call multi-class classification problems. So this is where you might have multiple categories that something might go into. My talk on Thursday at Condig, which Sam referenced earlier, I'm actually showing using ML.NET and C# to take a look at a video game information, such as whether or not the video game has alcohol or graphic violence or whatever the factors might be. And it's going to predict the ESRB rating the game might have, this unreleased game. So this is an example of a multi-class classification algorithm. So something is going to be one of these various categories, but we don't know which. So that's another example of a classification problem. But instead of having two, you have More than 2, at least 3.
Hey Matt, so you can do all the AI that you want with algorithms or ratings, but just don't mess with Die Hard. We can completely go off on a tangent and talk about that. But I mean, did your system try to figure out whether it is or not?
Yeah, it
You
came up
you,
with.
you have an answer for that.
I have an answer for that.
Okay, I won't steal your thunder then.
Yeah, it's okay. Yes, Virginia, Die Hard is a Christmas movie. Absolutely. I have videos and videos and videos about that, as well as articles about the whole process with Azure Machine Learning Studio. It's actually a really good way of learning Azure Machine Learning Studio. So check that out on mattondatascience.com. There's going to be probably 3 or 4 videos about Die Hard on there. But yes, I absolutely convinced my wife of the correctness of that argument, we'll say. So classification and regression are examples of what we would call supervised learning. With supervised learning, we need to provide historical information about something. And so we need to know, for example, how many minutes I needed to scrape off my windshield, or the value of a car or a spaceship, or whether this mole was cancerous or not, whatever it might be. These are both supervised learning, so we need historical data. Now, clustering is an unsupervised learning kind of thing. So instead of providing historical data, with a clustering algorithm, you give it your data and you say, hey, I need 3 groups. I need to have 3 clusters of data. I want you to figure out where they should be placed. Now, it sounds a little abstract, but let's put it this way. Imagine I had information on everybody who was watching this right now, and specifically where they are. Now, I don't have that information, don't freak out, but imagine I did have that information, and I had enough money to open, let's say, 3 burrito shops. I could use a clustering algorithm to determine the optimal location of each one of those 3 burrito shops, so that you all would have to travel the least amount of distance possible in order to get to the one nearest you. That's an example of a clustering algorithm. So with clustering, you tell it the number of centroids, that's these points here, these big green, blue, and red dots, and it's going to use mathematics to optimally position them. It could be geographically positioning them, like I mentioned before with the burrito shops, or it could be based on some sort of numerical attributes of the data. I've not done this project yet, but one of the projects I want to do at some point in the future is I want to take information about source code. I want to take information about the lines of code in a given file, maybe the amount of times that the file has been modified in a source code commit, and I want to look at clustering together different files. So you can look at files based on their similarity to each other in the behavior people typically associate with commits. Clustering is often used by marketing departments to cluster users together based on their activity levels. So you might have 5 different groups or 3 different groups or whatever the number might be. And you might have an email for frequent users, an email for new users, an email for power users, whatever it might be. So clustering is often used to group people based on the similarities. So these are the 3 that I would like you to focus on: is clustering, regression, and classification. But honestly, if you focus first on classification and regression, those are going to be probably the most useful to you because they solve more problems than clustering does.
Matt, before you proceed, folks, I don't know if I need to say this out loud, but like, I'm the annoying sidekick that just kind of stays on and asks dumb questions along the way.
You're my excuse to have a drink. It's fine.
There you go. So I'm going to ask you, the age-old thing that everybody talks about when we get into AI and data sciences. The ethics of it, like especially regression, when you talk about the biases. So what are your thoughts? Like, let's just take your Christmas movie example. Like, how do you cleanse your data? How do you try to give it clean data for it to learn and try to get rid of some of the human biases?
So data cleaning is 99%. Well, it's probably 90% of what you do in data science. Is you are going in, you're validating that your data doesn't have drastic outliers out there. You're making sure that you're only giving your algorithms the core information they need. For example, when I was doing this Die Hard experiment, I had to make absolutely certain that the algorithm never saw any information about Die Hard until it was making a prediction, because I would bias it one way or the other. But if you think about a more serious case, such as approving whether or not somebody gets admitted to a college or gets a loan or something like that, that's really critical. I'll talk a little bit more about ethics later on in this talk, but that's a huge deal. Yeah, we'll talk a little bit more about that in, I'd say, 20 minutes or so. But keep asking those questions. I'm actually paid to be interrupted in my day job, so I usually welcome it. So, but I want to briefly introduce you to the different other types of machine learning that we might do. So as you're starting out with machine learning, you're not going to start out with these things necessarily, but you need to be able to be aware that these are things that machine learning can do. So first of all, we have forecasting. Now, if regression is predicting a single numerical value, forecasting is predicting a window of numerical values. So for example, if I wanted to predict the high temperatures for the next 5 days, that's a form of forecasting. Predicting the stock prices for a specific stock within a certain window, that's another example of forecasting. So you're predicting a range of values based on time series data analysis. Anomaly detection. I don't know if you've ever traveled anywhere and bought something unusual, and your credit card company or your bank calls you and says, hey, I've frozen your account until you confirm whether or not you ate at this sushi place. That's a form of anomaly detection. We also use anomaly detection for detecting unusual network traffic or detecting unusual program behavior for antivirus software. So these are forms of anomaly detection where we're looking at the live data and finding our outliers and flagging them for review. I want to take anomaly detection and I want to start looking at commits. If we look at the at individual commits, you can find that most commits into source code fall into a particular pattern, but you do find some that are just radically different than any others, and those should probably be flagged for immediate review instead of letting them carry on a little bit later on. And I believe we can use anomaly detection to do this, but I've not attempted this project yet. It's another example of how we might try anomaly detection. Recommendation is probably one that most people are going to be familiar with because it's how services like Netflix and Amazon work. Any type of thing that's recommending content that you've not experienced before based on your prior behavior, that's a form of recommendation. So if I have just added a certain item to my cart in Amazon, it's going to suggest a couple other things. If I've just watched a video on YouTube, it says, hey, oh, you watched this video about this game. Oh, here's a couple other videos about this game. It's recommending things based on, well, first of all, based on similarity to each other, but also based on the similarity of users. So if Sam and I have similar buying habits or similar watching habits, and I watched a sci-fi movie Pandorum and I liked it a lot, but he's not seen it, Netflix might recommend Pandorum to him because it says, hey, you're very similar to this guy. You like the same things. You dislike the same things, but you've not seen this and he likes it. Hey, what do you think about that? That's how recommendation systems work.
No, sorry, I was just going to say, like, this is, the crux of, some of the big benefits we get. But this is also kind of how we often get into like echo chambers, right? It's just so much driven by this AI that we are kind of combining people of very like, mindsets all together, and you're all watching or, consuming the same things. And this is hard. Rocketman 2112 was, commenting on, the ethical aspects of it, which you'll get to, but removing human bias, that's a fascinating science on its own. Yeah, very true.
On recommendation, just last night I was on Twitter, as I often am, and it said, hey, you've liked other tweets like this. Here's a tweet. And it was a political tweet, and there's something a little scary about that. I'm like, I'm not sure I like that. So I did not interact with that tweet because I did not want to encourage that behavior from their engine. But at its core, social media works that way too. They work on recommendation systems based on their observed behavior of you. I want to try approaching code library recommendations by using a recommendation system. I want to say, hey, you're using C# and in unit to test things. Have you thought about using shouldly? Other people who tend to use these libraries that you're using tend to use this library. I think something like that would really help a lot of people learn more about programming. So that's a project I want to take on. And actually, this is one of my triggers for delving a little bit more deeply into data sciences because I had this need and I didn't have the skills yet for this. So there's a lot of really cool things you can do with machine learning. Pivoting a little bit, image classification. So when I teach arrays at Tech Elevator, I open up Matt's Pizza Shop, and we're dealing with pizzas. And one of the pizzas I offer in my pizza emporium to students is a glass shards pizza. Now, I'm not really feeding my students, pizzas with glass in them, but it helps make things memorable for them as I'm teaching them index out of range exceptions. Now, my last class last fall latched onto that idea so fondly that they actually baked a sugar cookie in the form of a pizza and put it in a pizza box, which I still have on display over there in my office. And I plugged this image that I took of this last fall into Bing. And Bing had never seen this before, but I did an image search with it, or visual search. And it says, hey, this is a pizza. I'm like, okay, cool. It found the visual similarity. It's not a pizza, but I like that it found that it was a pizza. It means my students are good bakers. And it says, hey, here's some similar images. Now I want to highlight this one over here. This image is actually a cake in the form of a pizza. And I think it's really, really interesting that it suggested this particular image based on this image. It had never seen this before at all, because I'd been using, my Android phone and had gone to Google Photos, and this is Bing. But it took a look at these sprinkles here, or whatever it might be, and it saw the texture was very similar to the white chocolate on this pizza cake over here. And because of the similarities, which it doesn't even understand, but its deep learning algorithms were able to say, hey, this looks very similar to this other thing. I think they're both pizza. And in fact, they're both desserts that look like pizza. So that's part of the power of machine learning and deep learning, is that we can find these associations in surprising ways.
So before we move on, just a quick comment here, and this stuff is fascinating. Maybe you'll get to this in a bit, but this is very computationally intensive, isn't it?
Yes.
Because like when you're doing an image search on Bing, that's something it's never seen, and it's trying to come up with these things. So if, just for context, so .NET, a lot of us work on .NET technologies, and .NET celebrated 20 years. And they were talking about some of the internal teams. Yeah, and Matt and me have been, doing .NET for a long, long time. Bing, actually. And so, Matt, you and me may be the only two users outside that are, fans of Bing. But I use Bing all the time, and they use .NET, and they were talking about like how computationally intensive these like classifications are. Mm-hmm. So it's quite fascinating.
Well, there's an interesting point there, because training our models is very computationally expensive. But evaluating a trained model, so if I've spent all my time training my model, and now I'm just sending it in new information it's not seen before, that takes a lot less time, because we're basically transforming a set of inputs to a set of outputs. And so it's a lot faster just to evaluate a trained model. But the process of training a model might take days, if for something really complex, and deep learning is something that it's got a lot of complexity to it.
So that might be kind of in the direction of what Rocketman was asking. How well does classification do on unstructured document images if you have a very large set already classified to learn from?
That's one that you're going to have to ask me about in a year. I can tell you that my inclination is to plug it into to Azure's Cognitive Services and its image service and see how it makes it. But if you have something very specific, you may actually need to not use like a pre-trained corpus of image data, but you may actually need to feed it a bunch of new custom training data yourself relevant to your specific problems. But that's not an area that I have delved deeply into yet. I just think it's pretty awesome. So if image classification is looking at a single image and extracting some context from that image, object detection is scaling that up a little bit. So here we are taking a picture of my dog and I playing hockey, and this is a PowerPoint mock-up, but this is what object detection does, is it looks at something, it says, hey, I not only do I see a ball, but I see balls in these particular bounding boxes. So you're identifying regions of the image that have the thing that you're looking for. And it's kind of silly to apply it to this problem here, but if you squint a little bit and you think about self-driving cars, they need to be able to detect other cars, stop signs, road markings, pedestrians. So they're looking at a live image, and saying, okay, there's a car here, here's its bounding box. There's a pedestrian here, here's its bounding box, and making intelligent decisions based on that. So object detection is finding things it understands in particular regions of an image. You can take that up a little bit by going into semantic segmentation. And this is where we're not just looking at bounding boxes, but individual pixels. This is still here from Squid Game, but this would be an example of semantic segmentation where we are identifying things that are humans. Because what could ever go wrong teaching a death robot what a human is? Says nobody who's ever seen Terminator. But semantic segmentation is we're extracting meaning for individual pixels. Facial analysis is another form of image analysis. So here we are doing object detection on an image to detect a face. But inside of that, we can do some other interesting things. You can look at the facial structure to say, hey, does this facial structure look like somebody I've been trained to recognize? You can look at a face and say, hey, I'm looking at the position of various muscles around the eyes and mouth. I'm guessing at some of the emotions in this image. And that's really interesting to be able to identify emotions based on an image. There's also some shadier things you can do with facial analysis. For example, you can use facial analysis to identify gender or ethnicity or similarity to other people around. Those are capabilities that I'm not so sure are going to lead us in good directions. And so that's getting back to our ethics concerns. In fact, most major cloud providers are now not selling facial analysis capabilities to police departments or the military or things like that, just because of human rights concerns. But it's really amazing what you can do with facial analysis. A couple of years ago, I was digitizing some of my grandfather's newspaper clippings. This is something that optical character recognition would help with. Optical character recognition, or OCR, takes handwritten or printed text and it converts it to plain text in computer language. So you can use this to extract text quickly from documents or do handwriting recognition. In a similar vein, we have text-to-speech and speech-to-text. Text-to-speech is really good for having an automated system like a service to monitor the status of your flights or an emergency management system. Speech-to-text is really good for personal digital assistants or visual voicemail. We can also do translation from speech to speech in another language. That's another emerging technology, and it's really exciting for us to have that. We have a lot of things we can do with text. So once we have text, we can perform natural language processing on something. We can identify key phrases in documents. We can basically do summarization with that. We can identify the language a document is in. We can identify the nouns and the person's, places, actions, all of these entities from text using natural language processing. We can even do sentiment analysis, which is what this slide is an example of. We are trying to find if a piece of text is positive or negative or neutral. So these are fictitious reviews from this talk and some things that somebody might have said about this talk, and as to whether or not they're positive or negative. This next one is something that's really exciting to me. It's one of the more complex ones out there. But reinforcement learning is basically giving an algorithm a way of interacting with your systems and evaluating or scoring its behavior. This GIF here is from a experiment that folks had done to try to evolve something that could cross these gaps. And as far along as it got, that was its score. And it learned how to basically jump over these little gaps. So this is really relevant for robotics, and we've seen this applied to video games as well. People playing Mario Brothers and the like, they've used reinforcement learning to train it how to do that. I want to apply this to some of my old games and just start doing some roguelikes with reinforcement learning. I think it's really exciting that a computer can find new strategies for established things based on things that a human might not think of, but totally work in games or in industry or whatever it might be. And so reinforcement learning is a really interesting application of AI. Finally, generative AI involves taking computer algorithm and having it generating something new, whether that's an image like we see here. I gave it a prompt to generate some pictures of a programming conference, and its answers were terrifying. You could have computers generate music. You can have computers generate textual descriptions. In fact, we've had some success automatically generating sports articles, just recapping scores for local baseball teams and basketball teams and things like that. So the ability for a computer to create something new, albeit if it's derived from other things it's seen before, is exciting. It's a very promising field. But I'm all about seeing computers surprise me, and not surprise me in like the form of a null reference exception, but surprise me by creating something new or thinking of something I never thought of. I think that's really fascinating.
So Matt, quick question. Some of the techniques that you talked about, except for maybe the generative part or the reinforcement part, many of those things are available to developers as like simple services. Like you can do like a lot of these things, like just making a cloud call. You don't even see any of the AI behind it. But is it true that all of these could be using deep learning and could be using some of those like deeper techniques behind the scenes?
Absolutely. I would be shocked if the text-to-speech and speech-to-text were not using deep learning. The image recognition, custom vision, computer vision, things like that. Those are things that really they kind of have to be using deep learning to be performing the way that they are. But Sam, I swear I'm not paying you money for this, but that was a perfect tee up for this next slide here. I want to encourage you to learn classification and regression as you're starting out in machine learning, and also clustering. But if you really want to take some of these things that are already built without having to learn a lot about data science, you could absolutely take advantage of Azure Cognitive Service and call out to these APIs that are pre-built and basically give it your own images and have it do the image detection for you. You can train it on what my face looks like or whatever, and show it a picture and say, nope, that's not Matt, or yep, that's Matt. These are all things that we have the ability to do now, and they're priced on a consumption model. So the number of calls that you make, that's going to be related to the bill that you get. So you don't have to have a very deep understanding of deep learning in order to take advantage of these things, which is super exciting. Fantastic question there, Sam. Thank you. Okay, so let's pivot a little bit from what we can do to how we do it. So if you're getting into data science, you're going to be getting into some sort of a programming language. The big two in the field right now are Python and R. Python, most people are familiar with. It's a programming language that's been around for a while, but it's really found a deep life in the form of data science. There's a whole lot of libraries out there around data science in the Python community, and that number is just growing over time. Python is really the default for data science, in my opinion. R is a statistical programming language basically built by non-programmers to do data science. It works, it's good. The community isn't quite as active as the Python community is, and your skills in Python are going to transfer over a little bit easier than your skills would transfer over in R. But both are perfectly workable and good places to go. I would just push you towards Python as a default, unless you have a good reason to go somewhere else. Now, if those two are kind of our current kings, Julia is this new and up-and-coming language, which I think we're going to be seeing a lot more of in the next 5 years. I've not looked into it in much depth at all, or worked with it yet, but it's another language to watch out for in the data science world because it's turning a lot of heads. Now, SAS is more of a legacy thing. It's used in certain industries and larger organizations. It's a statistical tool that can do a lot of data science, data analytical work. This is kind of fading away a little bit. In fact, my master's degree actually just announced over the weekend that they're retiring SAS and moving to Python and R, which I was very happy to get that email about because as I like working with Python and R as a programmer, and I like less working with a specialized tool that locks me into something. But it's a perfectly lovely, wonderful tool that's used in many places. Now, SQL is still going to be relevant for data science and data analytics. Anywhere you might need to do some querying on data, you're going to need SQL. So that's the good news. Your SQL skills are going to absolutely transfer, and they're going to be very relevant. And finally, the languages that you're using right now, whether it's C# or JavaScript or something else, it's very likely that there's some sort of a data science library for that language. For example, we have TensorFlow.js for JavaScript. We have ML.NET for C#, which I love on. I'm starting to work on an online course for that. We can already use our existing programming languages to do data science. But Python and R are a little bit more suited for brand new data science development. The really interesting thing is that a lot of the models that we might train them in Python or R, and we might be able to export them into a commonly understood format and import them into another language. This is a trend that we're starting to see on more. So ML.NET is .NET. I see your question there, Rocket Man.
Yeah, so on that question and kind of piggybacking off that, why is it that we need TensorFlow or ML.NET? Or maybe let me rephrase. What is it about Python as a programming language that makes it so suitable for this?
That's a good question. And when I first looked at Python, I was like, okay, well, this is cool, but why would I use this instead of C# or Java or whatever it might be? And I think there's some answers to that. One of them is that Python is easier for folks to learn if they haven't been in programming for a while. If you look at C# or Java, you can look at that language and see a lot of the syntax for that language derives from other languages that it's been derived on, and they've been derived on. We've almost gotten grandfathered into some of these words like virtual and void and things like that. And we forget about these things. But these are intimidating things for new developers to look at. Trust me, I know I have to teach new developers, and my default answer is Microsoft didn't ask me when I teach C#. But Python is almost a way of starting over for many people with a blank slate and having things that make a little bit more sense, or maybe a little bit more forgiving, less syntax involving. We're also seeing Python being used a little bit more in the college communities and in programming programs. People are switching more and more towards teaching Python as the programming language of choice. I think that trend is going to continue in the future. So Python is something that I think appeals to a lot of non-programmers who are getting into programming, and that can help them get into data science. And as a result, we've seen this community kind of grow around that.
Yeah, well said. And Goku Jax is pointing out F# can actually do data science as well. Yep. It looks like it's close to Matt's heart.
Oh yeah, I love F#.
I will actually go ahead.
The more I program, the less I trust myself. And F# as a programming language helps me find bugs that I would ship that C# wouldn't find yet.
And I second this thing about C#. I'm an old man. I've been doing C# for years and years, but it has gotten to a point where some of the things we are seeing in the latest iterations of the languages, it's like how much can a language evolve to a point where you kind of dig into some of the syntactical sugar, and there's just a lot that you just don't understand. Just simple like async awaits, you don't understand the state machines all that much. Yeah. So things are not so easy to just kind of jump into. Maybe that's why Python is just so easy to get in.
I think so. And Sam, just to prove my point a little bit here, take a guess how many different ways there are of working with properties in C#. Just numerical number.
Like getters and setters, or
yeah, getters and setters.
There's quite a few. I don't know off the top.
I think last time I counted, it was about 13. And new developers they're wanting to learn all 13 of them, but on top of that, they want to learn when they should use which one. And so this baggage that we keep adding to our languages as we evolve them, it does hurt those new developers. That's a whole different talk, though. I could talk to you on that for hours. But let's move on. Talk a little bit more about the aspects of Python that you might use as you're getting into data science. So when we're working with Python, a lot of the times we're working with tabular data, like a table in a relational database almost. And there's a library out there called Pandas that works really well with it. In fact, most things we can do in SQL, we can do in Pandas. It's really good at doing sorting and grouping and pivoting and filtering and all these mathematical operations. It relies on a library called NumPy, or numerical Python, to do very efficient multi-threaded operations on these data frames, these Pandas data frames. So it's able to work with data very quickly, very efficiently. But that presumes that we can fit all the data into computer memory at once. We can't always do that. And So when we can't do that, or when we really need distributed processing capabilities, we need to take advantage of something like PySpark, which it gives us a distributed means of solving problems. So PySpark is essentially pandas on steroids, where it goes out and it runs on a cluster of computers or multiple clusters potentially. So you got all these things contributing to your data. And we get pretty deep into distributed processing when we get into PySpark. But tabular data is something we're going to do a lot of in data science, because we got to analyze our data and clean it and make sure it's acceptable to us. Data visualization, we got a lot of libraries out there, such as ggplot is kind of the default one people will use because it's built into pandas, or it's associated with pandas anyway. There's also matplotlib. I really like the library called Plotly. It's got some very good, easy to use things that we get in Plotly Express, with very good features like zooming and tooltips that you can do in a single line of code. You tend to have a very good user experience when you're working with Plotly. If you need to create a dashboard, you can use the Dash library, or you can go out there and do something in D3.js. If you wanted to port your data to JavaScript, that works too. Machine learning. There's a lot of machine learning libraries out there. As a new developer, I would push you towards scikit-learn or Keras. I personally have learned a lot of scikit-learn because it's tightly tied to a lot of Microsoft's examples with Azure Machine Learning Studio. But Keras is another good one to learn. It's a little bit more object-oriented than scikit-learn. Additionally, scikit-learn does not do deep learning at the moment, but Keras does. Keras is a wrapper around TensorFlow. Now, TensorFlow and PyTorch, those are kind of our deep industrial power tools. They're more and more complex. A lot of things that you'll see out there in the real world are using these libraries, but as you're just starting out, these are not things that you need to worry about. It's sort of like trying to start out programming by learning assembly. Yes, you might be able to get a little faster, but you're going to spend all your time working on it, and you're going to get frustrated. So I would encourage you to start with Pandas, Plotly, and scikit-learn, and then move on from there. Those would be my recommendations.
So Matt, two questions here. Are these similar to what is a library in Python? Is this kind of similar to what like ML.NET would do?
Yeah, so a library in Python is going to be very similar to a NuGet package in JavaScript. A NuGet package in C# or .NET, and a npm package in JavaScript. Yeah.
Yeah. Okay. And like you said, like we can talk about the languages all day long.
Yes.
Rocketman, maybe you're showing your age here a little bit with like NCC. Yeah. So the point is like, the modern languages do sometimes, they do prevent us like from shooting ourselves in the foot, because like they stop us from doing, things that will lead to like memory leaks and other things. But Oh boy, like I don't want to write pointers.
We gotta keep going here. Yes. The discussion's great, but I got a lot of slides. So I want to make sure that we understand a couple of key aspects of data science. So when we get information for supervised learning, which remember that supervised learning is going to be regression and classification primarily, or at least that's what you'll start out with. We need to essentially take our data and split it into two halves. Typically, we'll take 70% of our training data, this is the historical data that we have, and we'll put it over here. And we're going to use this 70% of the data to train our machine learning model. It might be 80%, it might be 70%, somewhere in there. We're going to train our model to memorize and understand the relationships in this piece of data. This is a screenshot here from Azure Machine Learning Studio's designer, illustrating a split in a more visual way. So here we're taking information about movies. We're taking 80% of those movies or 70% of those movies. We're putting them over here. We're training a model to learn the behavior of those movies, the relationships between things. And the remaining pieces of data, the 30% or the 20% that we didn't take, now that we have our trained model, we're going to feed it this information, this data that it's never seen before. And remember, this is data that we have historical information about. So I know, for example, that Charlie Brown's Christmas is a Christmas movie. Or I know that, I don't know, I'm trying to think of a random non-Christmas movie, but some other random movie is not going to be a Christmas movie. This is trained data. And so I can evaluate my trained model to see how well it's performing against data it's never seen before. That's a really important thing, because if we don't do that, our models are going to overfit. They're going to memorize the training data, and they're going to be very good at that data, but they're not going to be good at handling data they've never seen before. So this is an important aspect of machine learning that we need to kind of keep back a little piece of our data to verify to the behavior of our models, make sure our models are not just performing really well against the training data, but not very well against new data. And this is getting back into that discussion that we started up earlier about ethics. The Microsoft has 6 principles of responsible AI, and we don't have time to talk about all of them, but we're going to talk about 2 of them. Fairness is the one that we were talking about earlier, and the ethics of things. For example, let's say that I'm building a classification algorithm to determine whether or not somebody gets a loan. It might be a homeowner's loan. I might have a bunch of historical data about people who have applied for loans and if they've repaid those loans over time or not. And I want to train my model to approve loans that it thinks will be repaid and reject loans that it thinks will not be repaid. Sounds like a sound business decision. So I take this historical data, I feed it to my model, it trains, it's got a good accuracy, and I go out there and I put it out into production. And now people are going out there and they're using this, and it's approving or rejecting loans, or recommending to some human to approve or reject a loan. Now there's a problem there because I might have trained a model and I might have actually trained a biased model and not even known about it. And let's look into that a little bit more. So let's say my data had information about somebody's salary, the location of their house, the number of years they've lived in their house, the number of years they've been in their job, information about their spouse or significant other, their salary, the number of years they've been in their job, all this stuff, and then whether or not they repaid their loan. That all seems like reasonable information for a loan calculation. But in that location of the house, we have the postal code or zip code, right? And let's say that I gave my algorithm 500 rows, 500 historical cases of loans, whether or not they've been repaid. Let's say that in that data, there's only 5 entities associated with a certain zip code, and those 5 people happen to not repay their loan. Well, what happens when somebody comes off the street and they happen to live in that zip code and they apply for a loan? It's very possible that the machine learning model said, oh, if something's in this zip code, I should always reject the loan no matter what. And this is a serious problem because zip codes are actually very commonly historically associated with racial segregation. And so just because I gave a machine learning algorithm a column that it didn't need, I may have accidentally opened the door for it to memorize something that might have been racially biased. So we need to be very careful about the columns that we give our data. If it doesn't make sense for a column to be there, let's remove it. If something could be a proxy for race or gender or age or something like that, we probably should remove something. Additionally, you want to make sure you are including everybody. That's our inclusiveness here. So you want to make sure that you have enough data to represent minorities, people with disabilities. You want to design your application for minorities, people with disabilities to benefit from, as well as everybody else. There have been some very well-performing facial analysis applications out there that have done very well in training and evaluation. But when we roll them out, they're horrible at detecting and recognizing African-American faces. This is another example of inclusiveness and fairness. We want to make sure that we are not biasing our applications. We want to make sure we're giving a very good representative data set to our algorithms, because they will learn these things. And we have libraries out there now like FairLearn, which are helping us understand and visualize some of these fairness properties. This is an area that we're getting better at as an industry, but it's still something we really need to be aware of as we are training our data. Very critical. Additionally, this is getting into our transparency principle. When we have a model that works, we need to understand why it works, the major factors of it. So this is my die-hard movie model. This is the various feature importance of this visualized in Azure Machine Learning Studio. We can see that the most important feature to this model was the release month of the movie. This is an earlier version of the model versus the final one I went with. But whether or not a movie was close to December was a major factor in whether or not it predicted if it was a Christmas movie. And if it was towards the middle of the year, it was a major factor for not being a Christmas movie. And that makes sense. Whether or not a movie is a comedy movie, yeah, okay, I can see that making sense for whether or not something's a Christmas movie. But if I plugged in my loan application and it said that zip code was a major factor in whether or not a loan should be approved, that's telling me red flags right there. Okay, so let's talk briefly about the whole front to back data science workflow. So as we're doing a data science experiment, we start by getting some data or validating some data we already have. We then explore that data. We do some cleanup on that. We prepare it for actual training. We do the model training, which we talked about. We're going to evaluate the way the model behaves. And if we like that model, we're going to go ahead and deploy it to production where people can use it. If we don't like it, we'll keep iterating. But once we deploy it, we got to keep monitoring it and make sure that it's going to be accurate over time. Sometimes we need to retrain our models over time. So with data acquisition, if you are wanting to start doing some data science right now, you may already have some data sets available to you. Information about fitness trackers or task management systems or systems at work, which you can ask for permissions to do some experiments with. Those are all sources of data that you can have. But there's also Kaggle.com, which is a data science community, and they have just thousands of data sets out there that you can use. My movies data set was from Kaggle. My ESRB video game ratings data set, which I'm talking about on Thursday, was from Kaggle.com. Right now, when I'm looking for something to do a machine learning project, I'm going out to Kaggle because there's a lot of really good data sets out there. If you don't know what you want to do, just go out to Kaggle and start browsing their data sets. It can give you some ideas. But you're going to acquire some data or verify some data that you already have. Once you have that data, that's when you're doing exploratory data analysis. You're plugging it into to Python or some statistical program, maybe Power BI or Tableau. You're visualizing the data a little bit, and you're starting to identify things like outliers in your data, or missing values in your data, or things that you might need to do a little bit of cleanup work for. For example, when I was doing my movies work, there were movies out there that had run times of weeks. I think they were like entire baseball seasons were considered movies for this data set for some reason. So these are things I had to make sure I didn't provide to my machine learning model during training because it could have skewed the results. So you would need to do some statistical analysis, some graphical analysis of your data to really understand its characteristics. You can also start to spot trends in your data by doing things like scatter plots. And once you do that, you're going to have some ideas of some correlations which may be present, and that can inform the types of features that you're going to give to your machine learning model as you're training it. When you are preparing your data, that's when you're going in and you are removing columns that you don't want to be present. You are fixing missing values in your data, whether that's by removing the rows with missing values or using an average or doing some other form of approximation. It depends on your exact data and your exact use cases. But you're cleaning up your data set in a repeatable and documented way so that others can make the same experiment. So this is a screenshot of my Python code for my my Die Hard experiment, so others can replicate that if they wanted to. But this is where you're going to spend a lot of your time is just analyzing and preparing your data, making sure it's clean and ready to go. Sometimes you may add new columns to represent certain things. For example, I added a column just for months and years, splitting that out of dates to help a machine learning algorithm key in on certain key factors. Once you have a prepared data set, you can feed it into a machine learning model training algorithm. This might be in Python code. It might be somewhere else. It might be ml.net. Who knows? Whatever you want to do. But you're giving it the information, and it's training a certain model to understand this. Now, this is probably the area that's the most intimidating for new data scientists or people just dabbling with this, because there are so many different algorithms out there, and to understand any of them, you have to get deep into the mathematics. This is one of the things I'm really excited about with data science. This is where we're changing a lot recently. We have things out there like ML.net's AutoML, which I'm talking about on Thursday, or Azure Machine Learning Studio's Automated ML, very similar name. These are both products that go out there and you tell it what type of task you want it to do. For example, I want to do a classification run. Here's my target column. Here's my data, and it's going to what it's going to do under the hood is it's going to take a look at all the different algorithms it has for that particular task. And it's going to apply all these algorithms. It's going to tweak the hyperparameters to it. And it's going to find the one that performs the best. It's going to do a bunch of repeated training runs and evaluate the performance of each model. So I, as a new developer or a new data scientist, I don't need to understand one algorithm versus another and all the parameters that go into each one of these things. It understands some of those things, and it figures out which one works best for me, and it recommends that model as my final model. And I really love that about the way the machine learning is going, because it's making it more and more accessible. Yes, it's good to understand the actual models it's selecting, but that's something that can come more over time as I start working more and more in data science and start working more and more with the various models, because there's so many of them, and they tend to be deeper in mathematics than anything else. So having a service like Automated ML on Azure or AutoML on ML.net that's going to actually go out and figure out these things for you is just phenomenal for a new developer. You still need to care about giving it good data, but you're letting it do the heavy math for you. Once you have a model, you need to evaluate how good it is. So just because it came up with, hey, this is the best model I found, it doesn't mean it's something that you should put out in production. If I have a cancer detecting algorithm that has a 50% success rate, it's like, okay, that's like flipping a coin, right? I need to make sure it's something significant. And if it's not good enough, then I need to start tweaking my data a little bit, start seeing what I can do with different feature engineerings and things like that. But if I'm looking at my data and I like the way it's behaving, I like the accuracy rates I'm seeing, and I believe that they're fair across different ethnic, age, gender boundaries, then I'm like, okay, let's ship this out to production. There are a lot of metrics out there associated with model performance, and they vary based on the type of machine learning that you're going to be doing. With classification, you're looking at, hey, how accurate is it? How much of the time is it correctly putting it in the right bucket? How much of the time is it putting it in the wrong bucket on accident? Is it more accurate at saying yes, something is something, or no, something is not something? If you're doing a regression analysis, you're looking at error. How far numerically off of the correct value was it? So if my machine learning algorithm tells me I'm going to be spending 90 minutes defrosting my windshield, and when it only took me 3, that's a pretty significant error. Versus if it's 4 minutes and 3 minutes, then yeah, okay, that's performing pretty well. But once we have something that we like, that's when we can go out and we can deploy it into production. So you're going to export your model into a format that works well with whatever languages you're using in production. So a Python model, I might export to Pickle, and then I can import it into another project. I could export to Onyx, which is an open neural network exchange format, which is something that works well cross-platform, and more things are supporting that. ML.net supports that, by the way. Or if I'm using Azure Machine Learning Studio, I can just right-click on a model and say, hey, deploy it. And it's going to go out there and deploy it as a web service, or as an Azure function, or Azure Kubernetes service, or Azure container instance, whatever it might be. I can take this trained model and actually deploy it out there as a web service, and other things can just start making web service calls to it. But that's basically how you go out there and do data science and train and deploy your models. But once you're out there, you need to keep watching them, make sure they remain accurate, and maybe periodically retrain them and redeploy them as new data comes in. So let's start to wind down here by talking about the people who do data science and the skills that they have and how you can get those skills. So we have data scientists, who are the people out there training machine learning models. We have data engineers, who are, I like to call them data plumbers, but they're helping data get from various systems to the place where they can be analyzed by the other people on your team. You have your data analysts, who are looking at data to try to extract raw insights from them and communicate those insights to other people. So data analysts need analytical thinking skills, and they also need communication skills. They may or may not be a programming role, versus everything else on here is definitely a programming role. It just depends on the organization whether a data analyst is a programming role or not. Some of them might be using Power BI, some of them might be using Python. It depends on the organization. AI engineer is a role that Microsoft says exists based on some of the certification exams I've seen out there. But this is really more about taking in trained machine learning models and building applications around them, using Azure Cognitive Services, building chatbots, things like that. So if you like training machine learning models, data scientist is for you. If you like helping data flow reliably and efficiently, that's a data engineer. If you like analyzing data, finding insights, that's a data analyst. If you just like building cool apps that take advantage of AI and machine learning, it's an AI engineer. So these are your major ones. But you also have things like a database administrator supporting them. Some notes here. Your data engineers in particular need to be able to handle big data. So they're dealing a lot with data warehouses and data lakes, which is just data at scale, whether it's structured or unstructured. They're dealing with extract, transform, and extract, load, transform processes, batch processing, and just various forms of distributed processing. So these are more programming libraries that your data engineers in particular are going to have to deal with, versus your data scientists are probably going to be dealing more and more with the mathematical nitty-gritty of the machine learning models and the training procedures for them. My colleagues at Tech Elevator are awesome. The Pathway program is our program that helps people with careers, and they helped me out by pulling some salary information from data science roles in the Columbus area in January of this year. And this is those roles compared to a software engineering role. And you can see that these roles are roughly comparable. Data analysts make significantly less than the other types of roles, but it tends to be apples and apples. Very similar roles. Your data roles tend to have maybe a higher cap at the higher levels of expertise. But I would not leave software engineering for data science just for money, because by the time you build the skills that you need, the market may have changed. The accessibility of data science may have improved even more. But you're going to be looking at about the same pay scale as you might see with software engineering. So salary expectations, the salary's there, but it shouldn't be your main motivator for getting into this stuff. So let's say you're you're a software engineer and you want to get into data science. My recommendation to you is to start building those skills. You don't necessarily want to leave what you're doing, but you want to start doing a little bit more of data science in your day job. So what you need to do is you need to start formally training yourself on data science. I'm not saying go get a master's degree. I have teaching specific reasons for why I'm personally going to do that. But you can learn a lot about data science without going out for any formal education in it. We'll talk a little bit more about how you might do that, whether that's building a project or watching talks like this one, reading books, whatever it might be. But you're going to start building your data science skills. And as you start making your baby steps on this path, you're going to tell people what you've been up to over lunch or just at team events or whatever it might be. It's like, oh, I've been experimenting with regression algorithms, and I found out a way of predicting the number of accidents that are going to be on my street over the next 4 years or whatever it might be. And as you start building confidence and other people start thinking about you more in that context, you're starting to think about what you do in your day job a little bit more from a data science perspective. And you'll come up with some ideas for either analyzing data or carrying out an experiment with your day-to-day job. So you come up with this idea and say, hey, I think that we might be able to apply data science to predict the number of customers that we might lose, or whether or not we're going to lose a specific customer in the next 6 months if we trained a model for this. Do you mind if I spend some of the time while we're waiting for QA to verify things, or we're waiting for the build to finish, or Friday afternoons when everybody's goofing around? Do you mind if I spend some of my time devoting to this project? You might get a no, in which case, well, you can't do this for work. You might need to start looking for a different department or a different job where you could try that if it matters to you. But once you get that approval, go off and do those experiments. Don't do them in production. Don't do them with data that you shouldn't be able to access. But do those experiments. And when you have some results, tell your boss about them. It's like, hey, I think, I got this 80% accuracy of predicting whether or not somebody's going to churn. Is that valuable to us? Is this worth us investing more time in? And you start doing this iteratively. So you say, hey, I got this experiment. This is what we found. It's not ready to go yet, but I'm going to keep learning. And I got this other idea for an experiment. And what you're going to find is you're going to build more skills. You're going to get more people thinking about you in those contexts. You can get them thinking more about how data science can help with what they're already doing. And when they want to try to do something more, well, they're going to talk to you. They're going to at least involve you in the process. Or they're not, and you can find another job if it really matters to you. It depends on what you want. But just tinker with stuff, and you're going to find out if you like this or not and how much that matters to you. Now, if you decide you're going to go out there and just leave development and become a data scientist, you need to be able to pass a data science interview. I've never interviewed for a data science role. I have no intentions of interviewing for a data science role. My job is to teach people. But you need to be able to pass it much as the way that you would pass the software development interview. So what have you done? What experiments have you done? What's your portfolio look like? You need to be able to convince somebody that your software development skills and knowledge are still relevant and useful. But you also need to be able to handle the types of interview questions you might see in a data science interview. And for that, I would recommend a book by a couple people who I'm not going to try to pronounce their names, but Ace the Data Science Interview is a fantastic book. I have a copy. I've not read all of it yet, but it is a lovely skim, and it covers all aspects of data science. It is an intimidating read, but it's going to help you understand a little bit more about the nature of data science and data science interviews. So this would be my default starting resource for you if you wanted to go out and interview, but build your skills first and then interview. But again, interviewing never hurts you. Rarely hurts you. So let's close a little bit by talking about how we would learn data science. If you wanted to go out there and learn data science, I already told you to start with regression, classification, and clustering. But let's start just by doing data science. It's how we learn something. So pick a machine learning task that interests you, such as classification or regression. Find some data set or project that's interesting. So for example, I had read about classification. I really wanted to try a classification experiment. I wasn't sure what type of thing I wanted to classify. And then I came across something on Reddit, a meme around Die Hard. And I'm like, hey, honey, what do you think about Die Hard? And she gave me the wrong answer. So that was my excuse to get into a classification experiment. It wasn't really to show her who's boss. But, find some data, find an experiment, go and do it. You're going to get stuck, and that's okay. But reach out to people, Google stuff, ping me on Twitter. That's fine. I'm fine with that. I might not give you an immediate response, but I love helping people learn new things. And once you learn something, share what you've done, whether it's with your family or friends or coworkers or whatever it might be. You can even post about it on Dev2 or on your blog or wherever it might be. LinkedIn is fine and appropriate as well. But just keep doing this stuff and you're going to learn. There's this tendency to look at something as an all or nothing. So let's say I know nothing of software engineering. I'm trying to get into software engineering. Do I need to know Kubernetes and containers and assembly language and all of these things? I don't need to understand the breadth of software engineering to start doing software engineering. Data science is the same way. Pick a narrow area, take a level in something, and then start adding little skills to it. So data science is really this thing where you're going to start little projects and you're going to add little bits and pieces of new technologies. And as you're working on one project, you get ideas for other projects. Another great way of learning more about data science, or anything really, is to commit to writing an article about it or commit to giving a talk about it. You're going to force yourself to learn a lot more and focus your communication in a way that other people can hopefully understand. But just think about adding things bit by bit as you focus on things. There's plenty of questions you can ask me that I'm not going to be able to answer adequately, and I'm going to be honest about that, and that's fine. But it's a journey, just like learning software engineering is. Major question people have is, what about math? I get this question a lot around software engineering. Matt, can I really be a software developer if I don't understand trigonometry? And people ask this question earnestly. And my answer is, if you can do a early high school math level word problem, you're going to be okay, right? If you understand exponents, great, that's helpful. If you don't understand exponents, you might have a little bit of a learning curve reading some things with software engineering, understanding big O and things like that. It might be a little bit harder for you, but you can go off and do software engineering. Data science is somewhat similar. It's not completely similar. A lot of the data science algorithms or machine learning algorithms use linear algebra and calculus under the hood. Certainly learning those things is going to be helpful to you as you start to understand how those work, but they're not mandatory for starting out. I would advocate probably you can do a lot of good without knowing much linear algebra or calculus at all. But learning those things is going to help you out. However, statistics is one of those things that you're going to greatly benefit from as a data scientist, and it's going to be a liability for you if you don't understand I would say grade school, high school level statistics. So taking a refresher on how to read a box plot or median, mode, mean, all these little statistical things, understanding the idea of a distribution, of a curve, like a bell curve or normal distribution, and standard deviation. These are all things that are going to help you understand statistics and data science. So if you haven't taken a statistics class, if these things that I have on the screen for statistics are confusing to you, or more confusing than not, you probably ought to watch some YouTube videos around it, or maybe take a Coursera course on it. But it's not something that should stop you from starting. But it is going to be very helpful for you to take a statistics refresher. So if you're looking for more formal ways of learning data science, Kaggle.com not only has data sets, but they also have some great projects and courses that you can do for free. A classic one that people do is predicting whether or not somebody would die or live on the Titanic. This is a classification problem. I've actually not done this problem yet because everybody does this problem. But this is a great way of learning. And you're going to be able to see from other people's notebooks as well, like how they approach data science solutions. So Kaggle is a great resource for you. Coursera really benefited me a lot. I went through a number of specializations for data science. This top one here, Python 3 programming specialization through University of Michigan, is a fantastic specialization. This is a series of 4 or 5 courses. The last course in that series talks about computer vision, and it's a lot harder, a lot more difficult than the rest of them. You get a lot less help, but you go through that course, a series of courses, and you're going to learn a lot about Python and a lot about pandas and NumPy and all these really cool core libraries. So Coursera is a great way to go through. You can audit these courses as well. You don't have to pay for them. If you really want something a little bit more formal, you can go out for after professional certificates and certifications. Coursera actually offers a series of courses that result in a professional certificate through either IBM or Google. I don't recommend the Google Analytics certificate. I feel it's very, very, very entry level, but the IBM ones are very, very good. I'm very happy with them. There's also, not listed here, these are the ones I have. There's also the IBM Data Warehouse Engineer one, which I have, but they don't have a graphic for. And then there's the IBM Data Engineer one as well, which I'm still working on. Microsoft has some great AI certifications. Azure AI Fundamentals. This is probably the #1 one I'd push you towards if you'd like to study for it. It takes about a week to study for this test. It's actually a very fun one. And you get a nice little badge that doesn't expire, and you can put that on your resume. Azure Data Fundamentals is also good. I thought it was less fun than Azure AI Fundamentals. But if you feel like you don't understand the data ecosystem out there, it's going to help you understand a little bit more about extract, transform, load, and things like that. Very good ways of building your skills in a more formal way. But whatever works well for you is something that you should go after, is my opinion. If you work well from articles, I write a lot about data science at accessibleai.dev. Typically, when I record a YouTube video, I'm also doing an article for it. So this kind of goes hand in hand with my content, and most articles have a YouTube video embedded in them. There's also the Towards Data Science publication, which is a Medium publication, which is why I pay for Medium now. They have really, really high quality content. If you're asking how high quality it is, well, they rejected my article about Die Hard. I'm still bitter about that, but they're very, very good. If you like YouTube content and you don't mind the glare off my forehead, you can go to mattondatascience.com. I'm doing a lot about Azure, Machine Learning Studio, and ML.NET. So really Azure and C# based machine learning. O'Reilly has a series of books with white covers, which are really good. They tend to get in more depth than you might need, but they're good. They're nice and accessible books for beginners and experts. Really like this series quite a bit. And again, everything I'm referencing here, you can go out to matteland.dev/tryds, and you should be able to find my resources for these things. My final ask for you, if you go out and do something awesome in data science, please tell me. Send me an email at matt@mattondatascience.com, ping me on Twitter, send me a message on LinkedIn, whatever it might be, but let me know, because I love seeing the things that people build with this stuff. If you're curious more specifics from a single project, this Thursday I'll be talking at Condig about using ML.NET to predict video game ESRB ratings with C#. That is a multi-class classification problem that we're solving there. Sam, I know we went a little bit over. I apologize for that, but the questions that we had in line were very good. What final questions do we have before we wrap things up?
Now, this is wow. This is so much knowledge you're dropping. And again, I come back to like how much of a zealous like learner you are. Like I remember like a few years back when you were kind of getting into this, like you were just probing, and here you are with your certifications and all this stuff that you're taking in. So good for you, and thank you, for giving us pointers along the way. Looks like Rocket Man had to run. Messi's pepperoni. That's ringing a bell, but not quite. Is that Columbus?
Yeah, they're around Columbus, I know for sure.
Ah, interesting. Okay, I didn't know that.
I need to figure out what to hear for myself.
Yeah, so see, that's what we are missing out when we are virtual. Yeah. But hey, I do.
Pizza and wings.
I try. We try aligning some, Mondays to be, pizza nights. It doesn't always happen family wise. But let me ask you one thing here, Matt. Like there's a lot of good. There's a lot of things to ponder with data science. What is something you have come across over the years? A model or a system that works really, really well that you're impressed with?
Well, I mentioned the image search earlier. I think that's maybe one of the more recent ones that surprised me. I think that Amazon and Netflix both really kind of wowed me with their ability to recommend relevant content towards me. You see the same thing with music. You see the same thing with YouTube. All of it's fallible. All of it's very confusable. But it's really interesting that we have this kind of thing. The machines that can sort of learn our habits and learn our behaviors, which is a little terrifying, but also helpful. I think
that's well said.
Honestly, that sums up data science. A little terrifying, but also helpful.
Terrifying and helpful. Yeah, well said. Well said. Yeah. I've been, trying to get a little bit into solar, and you do one search anywhere, and they just like bombard you across all the different platforms.
Yeah.
So yeah. All right, then. Yeah, it looks like the next time I'm in Columbus, Ohio, I need to try Massey's Best Buy in town. Oh, that sounds really good right about now. All right. Well, thank you so much, Matt. You
My
are
pleasure.
A phenomenal teacher. I'm just glad to be, to be calling you a friend over the years, and you've kind of seen this user group evolve. We would, love to have you back any number of times you come and teach us new stuff.
Happy to help.
All right, folks in the chat room. Thank you for hanging out with us. Like I said, we are going global, so if you have an interesting idea, if you have something you're doing with data science or anything software engineering, any platform, any language, ping me, ping us so we can have you on. Come and share your passion. This is pretty informal of a stage, and we just want to learn from each other. All right, so with that, all right, and Rocket Man is dropping the link to the Massey's Pizza. There you go. Okay, so with that, we're going to call it a day here on stream. I know we are a little over, but if anybody wants to just hang out just for a few minutes on Teams, just turn on your camera and show your face and say hi. I'm up for it for a little bit, but I am starving as well, so not for too long. Yeah. All right, that's it from us, Twitch and Matt. Thank you again so much, and have a great night, folks. Bye-bye.
See you soon.